8051 Assembly Language Arithmetic Instructions. A complete list of the assembly language instructions can be found in the 8051 instruction set document. This document can be easily found on the internet. These are the instructions. The instructions can be categorized into 5 functional types: data transfer, arithmetic, Boolean variable, control transfer, and logic. This table and the following table show all the 8051 data transfer instruction. This table and the following table show all the 8051 arithmetic instructions. Let's recall the architecture diagram of the 8051. The PSW or Program Status Word Register contains information on the status of the 8051. The PSW is an 8-bit register. These numbers D0 to D7 are the bit addresses of the bits inside the PSW. We will be particularly interested in the carry flag and the overflow flag for the topics to be discussed here. Let's look at the addition instruction. Add accumulator with immediate data 55 hex. This is the instruction mnemonics. Let's try an example of adding two numbers, D4 and 55. The number D4 hex is moved into the accumulator. The add A with 55 hex will add the content in the accumulator with 55 and leave the results in the accumulator. Let's analyze the addition in binary. This is the binary of D4 and this is the binary of 55. 0 add 1 will result in 1. 0 add 0 gives 0. 1 add 1 gives 0 with a carry of 1. The carry in of 1 add with 0 and 0 result in 1. 1 adds 1 gives 0 carry 1. 1 0 0 give 1 with no carry. 1 1 results in 0 carry 1. 1 1 and 0 give 0 carry 1. The result is 29 in hex and it is stored in the accumulator. What about this bit? This bit is stored in the carry bit in the PSW. If the addition results in no carry, then this flag is set to 0. Let's take a look at another add instruction called the add with carry, ADDC. This instruction adds the content in the accumulator with the operand, which is immediate data 55, and the carry flag. The carry flag could be 0 or 1. Let's try this example. Assume the carry flag is currently 1. Let's go through the addition. 0, 1, 1 gave 0 carry 1. 1, 0, 0 gave 1 with no carry. 1 add 1 results in 0 with carry. 1, 0, 0 gave 1 with no carry. 1 adds 1 gives 0 carry 1. 1 0 0 give 1 with no carry. 1 adds 1 result in 0 carry 1. 1, 1, 0 give 0 carry 1. The result is 2A hex and is stored in the accumulator. The carry 1 will be stored in the carry flag. The subtraction instruction. The subtraction instruction subtracts the immediate data from the accumulator with borrow. What does with borrow means? Basically, the accumulator is subtracted by the immediate data and the carry flag. Let's try an example. The clear C instruction clears the carry flag to 0. The instructions subtract the immediate data E5 hex and the carry flag, which is 0, from the accumulator which contains D4 hex. Let's take a closer look at the subtraction. 0 cannot be subtracted by 1. Borrowing is needed. This bit 1 becomes 0 after lending a 1 to its neighbor. The neighboring bit becomes 1, 0. The binary value of 1, 0 becomes 1 after lending a 1 to its neighbor. 1, 0 minus 1 minus 0 gave 1. 1 minus 0 gave 1. 0 cannot be subtracted by 1. Borrowing is needed. This bit 1 becomes 0 after lending a 1 to its neighbor. The neighboring bits becomes 1, 0. The binary value of 1, 0 becomes 1 after lending a 1 to its neighbor. Now this is 1, 0. 1, 0 minus 1 is 1. 1 minus 0 is 1. 0 minus 0 is 0. 0 cannot be subtracted by 1. Borrowing is needed. This bit 1 becomes 0 after lending a 1 to its neighbor. The neighboring bit becomes 1, 0. 1, 0 minus 1 is 1. 0 cannot be subtracted by 1. Borrowing is needed. This bit 1 becomes 0 after lending a 1 to its neighbor. The neighboring bits becomes 1, 0. 1, 0 minus 1 is 1. 0 cannot be subtracted by 1. Borrowing is needed. A 1 is borrowed and this bit becomes 1, 0. 1, 0 minus 1 is 1. The result in hex is EF and it is stored in the accumulator. The carry flag is set to 1 to indicate that a borrow was needed for this subtraction. The multiplication instruction. The multiplication instruction multiplies the content in the accumulator with the content in the B register. The result is stored in the B register and the accumulator. What does the 8 to 15 and 0 to 7 mean? Let's take this example. The immediate data 21 hex and 55 hex is moved to the accumulator and B register respectively. Let's work out the multiplication. 1 multiplied 5 is 5. 2 multiplied 5, supposedly to be 10, but we are using hex number, therefore it is A. 1 by 5 is 5. 2 by 5 is A. Perform the sum. 5. A plus 5 is F. A. The answer is AF5. F5, which is a lower bit, bit 0 to 7, is stored in the accumulator. A, which is the upper 8 bit, bit 8 to 15, is stored in the B register. The divide instruction. The divide instruction divides the content in the accumulator by the content in the B register. The result is stored in both the accumulator and the B register. Let's take a look at this example. The D means that the number presented are decimal number. The instruction means divide 15 by 10. The results are 1 with a remainder of 5. The quotient is stored in the accumulator. The remainder is stored in the B register. What happens if the instructions are written to make a division by 0? The mathematical answer is infinity. Therefore, the contents in the accumulator and the B register are undefined. The overflow flag in the PSWs is set to 1 to indicate this condition.